Okay. Good morning, good afternoon, good evening, everyone, wherever you are. I am Nick Chase from Mirantis, and I want to welcome you to today's live demo, Make Your Container Images Safer and More Reliable with Harbor, the Cloud Native Registry. I want to first introduce our speaker today, Peter Rusica. Peter, why don't you go ahead and introduce yourself, actually?
Yeah, sure. Thank you, Nick. So my name is Peter Ujička, and I'm working for Mirantis as a deployment engineer. And currently, I'm helping our customers with migration of their application into the Kubernetes, into containers, etc. Because that's quite popular in these days, and Kubernetes can make a lot of easier things for you. So today, regarding the agenda, I will introduce you the Harbor project, its history and development. Then I will tell you more what the Harbor is, what are its features, like replication, vulnerability scanning, etc. And I will also cover a few slides about the architecture of Harbor. Then I will jump into the demo where you can see how you can install Harbor into Kubernetes. I will show you some operations with HELM charts together with the Harbor web interface. And of course, I will tell you more about the container images in Harbor, about the replication, security, etc. And then I will cover the project settings in Harbor. So that's pretty much in short what I'm going to tell you. So let's move on. What's Harbor? In short, Harbor is a cloud-native registry where you can store your container images, and it also supports the Helm charts, so you can put the Helm charts into Harbor as well. Why we need container registries at all? So if you are a developer working with a container, you usually use the Docker file to build your container image. And then you can run the container image in your environment, on your laptop, or in your server. But the registry comes handy when you want to share this image with your colleagues or with some third parties. Then you can push this container into the registry, and based on the settings which are done on the registry side, the other guys can download or pull the container image and run it in their own environment. Of course, they don't need to build the image again from the Docker file. They can just download it and run it in Kubernetes or in any other environment which is supported. So that's one of the main reasons why we are using Docker registries. Container registries, if you ever work with containers, most probably you heard about Docker Hub. So there's a huge amount of Docker containers. And of course, I shouldn't forget about Quay, which is from Red Hat. And almost every cloud provider like Azure, Amazon, Google, they all have their own container registries. As you can see on this slide, most of these registries are cloud-based, so they are already running on the internet, so you don't need to install them. And that's, of course, the advantage that you can just use them or pay for using them. But if you want to install a container registry on your own machine into your environment, then you can use, of course, Docker registry. You can use Harbor, which I'm going to talk about right now, and few more. But the list is much shorter than the previous one. So that's why people from Harbor start the project, because they decided to create a new container registry from scratch, and that's what I'm going to talk about. If I describe just a short development cycle, so the developers usually build the application, and they are also responsible to build the image. It's usually done through some kind of CI/CD, but it's not part of this slide. But the image needs to be built, and then the image is usually pushed into some registry. It doesn't matter if it's Harbor or if it's something else, but usually in this case, the Harbor will allow you some more features like scanning the image for the vulnerabilities. It can also you can also check if the image was properly signed by the developer or by management. Doesn't matter. And then of course you can run container image on the Kubernetes environment or in the Docker environment, for example. So this is just a short slide how it works and what you can expect from Harbor. Just a quick introduction into Harbor history. So Harbor was created in VMware in China. It's under Apache 2.0 license, and if you will find the Git repository on the GitHub as well. Few important dates in Harbor lifecycle. It was created in 2014 in VMware, as I mentioned before, but it was at the time it was a closed source project, and in 2016 it was open sourced, and 1 year ago in 2011 it became incubation project of CNCF, and it gains a lot of popularity from the time. You can see the contributors are mainly in US and China, and maintainers and contributors are almost all over the world. Let's go through the Harbor features. So, of course, as almost every project, Harbor does have the access control. It means that you can create your own users, or you can use Active Directory or LDAP to integrate users from these using these services. You can also use the OIDC, which is OpenID Connect, and configure the role-based access control, which is part of the access control feature. Then we have replication. That's handy if you want to replicate the container image from third-party registry, for example, from Docker Hub or from Amazon, Google, or anything else. So Harbor supports both way replication. Vulnerability scanning, that's, I think, one of the most interesting features of Harbor. So every container image which is stored in Harbor can be scanned, and you can see if there are any security holes or issues with the container. I will show you the demo, so it will be for you much easier to understand when you see it in the real life. Content trust. By default, usually the enterprises are also signing every image which they are running. So Harbor also allows you to see the digital signatures, which is provided by the Notary project. I will tell you more about it later. I also mentioned before that HELM chart is supported by Harbor, so you can also use HELM chart repositories in Harbor. And Harbor has the web interface through which you can manage all the operations. And of course, the web interface is using the RESTful API, which is basically the main entrance into all the applications which are running inside the Harbor. Most of my demo is going to use the RESTful API because it's much more easier for automation and for the testing. And A harbor can be installed into three multiple ways. You can use Docker Compose, that's the most easiest one. You can easily run Harbor on your laptop or on single server just by running Docker Compose. Then you can install Harbor into Kubernetes using Helm charts. That's what I'm going to show you. And you can also use Bosch for the Cloud Foundry. Let's just go quickly through the main features which I mentioned before. So regarding the access control, there are three ways of, three levels of giving the permissions to the users. Of course, the most basic one is guest. If the user is marked as a guest, he can only pull or download the images from Harbor, nothing else. Developers can do much more. They can at least pull and push the images, upload and download, and admins can do the rest. I shouldn't also forget that everything is based on the role-based access control, RBAC, airbag. So you can you can create groups of guests, groups of developers, groups of admins, which has these rights. There is also a special account which is called a robot account, which is completely separated from all of these. And the robot account is usually used for, let's say, Jenkins CI, which only needs to pull the image into the Harbor and nothing else. So you can enable, for example, the Active Directory as an identity provider, and robot accounts are completely separated from that. You don't need to have special accounts in your Active Directory. Replication. Harbor currently supports a few registries, container registries, which are out there. It's Harbor itself. It's of course the Docker Hub, which I mentioned. And in the latest demo, I saw the Harbor also supports the registry from Azure, Google, and Amazon. So all of these are covered. And there is Huawei Container Registry as well. The replication is quite easy to configure. You can configure the filters, so you don't need to replicate all of the images, just the ones which are matching the regex. It can be cron-based, so let's say every night, or you can trigger it manually. So replication also supports push and push mode. Helm charts replication is also supported, but I haven't tried that, so it should be working. If we are talking about replication, I shouldn't forget that you can easily use Harbor for the horizontal scaling. It means that if you upload one container into something which is called master Harbor or the primary Harbor, then from this Harbor, this image can be replicated into the smaller Harbor instances, and then the users can contact directly these small instances. This picture is probably better, so you can create this as a master instance and let Harbor replicate the containers all around the world, and then the users will just use the closest repository of Harbor. So that can be handy as well. Vulnerability scanning is based on the Red Hat project, which is called Claire. It was CoreOS previously. So if you pull the image into the Harbor, which is based on these operating systems, you can just click on the image and do the scanning easily. And if the image is based on one of these operating systems, it will be scanned. So this is not going to work with, for example, just a simple Go binaries, because they don't have operating system inside the Docker containers. Or Let's move on. Image signing. This is done by the third-party project Notary. I believe it's created by a Docker company, and it usually uses all the features which Notary allows you, so signing the images in our case. Harbor architecture, here are the third-party services which are inside the Harbor. So it's a Docker registry for storing the images, Chart Museum for Helm charts, Claire for the vulnerability scanning, and Notary, which I just mentioned. Harbor is also using the PostgreSQL database to store the users and the data. And it's also used by the Claire, because Claire needs to download the vulnerability data from the internet, and it's storing them into the SQL database. Of course, you will need some storage for storing the Docker containers and other Helm charts, for example. Let's move on. This is how the Harbor installation looks like in Kubernetes. So you usually have a load balancer in front of your Kubernetes, which is splitting the traffic into the Kubernetes nodes. Then it goes to the Harbor services. And from the Harbor services, the traffic goes to the proper pods, which are sharing some of them are sharing the storage. I shouldn't forget that Harbor is also using the Redis as a memory database. In production, it's a good idea to separate the PostgreSQL from your Kubernetes, or have the external PostgreSQL to get a better performance. But that's for most of these projects. Let's go to the demo right now. Let me make it bigger, yeah. So this is the architecture which I prepared. So we will have one instance of the Harbor, which is using few more third-party projects like Engine Ingress for getting the traffic into the Kubernetes cluster. Then I'm using Cert Manager to allow the Let's Encrypt certificate authorities to sign my my certificates, and then I can use the fully validated certificate in my Harbor instance, which you will see. I also installed the Active Directory server because I want to show you the integration between Harbor and AD, and that's pretty much all. I'm also using the DNS in Amazon and Elastic Load Balancer, which is in front of the AKS solution. So let's make it smaller. Yeah. So all the thing which I will be doing is using this domain, which is mailapps.dev. So you will see it a lot. Here is my Active Directory server. So if I open the users, I already pre-created few users to have it there. So here are some users, and here are some groups. I will tell you a little bit more about that, but this is basically the Active Directory service which I'm going to use for the authentication. Let's close it. My Kubernetes cluster actually has 2 nodes. This is one of them, and here's the second one, which are running for about 3 hours. So it's nothing complicated. It's AKS cluster. So it's running in Amazon. Here I'm. Okay, one more mistake. Sorry for that. I forgot to change the environment into production.
That's how you know it's live, folks.
Yep. That may happen. So let's just skip it quickly. Anyway, here are the information how I installed the Harbor. The thing is that I'm not going to show you the Harbor installation because I already pre-installed Harbor, because it's usually take about 40 minutes to download the Claire vulnerability data, and that's why I pre-installed the Harbor. So you will not see the Harbor installation in live, but here are the output if you are interested in it. So you can see the Harbor contains the Chart Museum, Claire, and Registry, which are the third-party project which I mentioned when I was showing you the architecture. Here's the ingress certificate, which was created by the cert manager. So I'm going to use the signed certificate by Let's Encrypt. Yeah, here are the commands which I used for the Harbor installation. You just need to specify the few DNS, fully qualified domain names, and the certificate, the secret which contains the certificates. In my case, it's this one. Let's Encrypt environment is always production, so it's basically this one. And so installation took just a few minutes, but then it took about 30 minutes to download the vulnerability database. If I open the ingress, I can see that there are just two main domains which are handled by Harbor. It's Harbor mylabs.dev, where the web interface is running, and Notary is used for signing the container images. Yeah, if you decide to not use the fully signed certificate by Let's Encrypt or validated certificate, you need to do a few hacks, like you can see here. So I'm just going to skip it because it's not relevant for this demo. It's just for the testing. Here, as I mentioned before, it's an LDAP search which is talking to my Active Directory server. And in the Active Directory server, I have the AD03 group containing AD user 05 and 06. That's important because I'm going to use this authentication in my Harbor instance. So let's open the Harbor itself. It's the web interface of Harbor, nothing complicated. Here is the vulnerability database, which was updated a few hours ago. That's the part which I was talking about. And of course, you can configure the authentication. You can use database, which is completely in the Harbor mode, so you can add users as you want. You can use LDAP or Active Directory. Then in that case, you will not be able to add any users because everything is in LDAP server. UAA, that's used for the Cloud Foundry, and OIDC, you will use this authentication in case, for example, you want to use the Google accounts. So if your company is using G Suite in Google, then this is a choice for you. In my case, I will use Active Directory, and I will configure it again through the API. So most of these examples will look like that. Of course, you can always fill it manually or click on the web interface. What's important right now that the LDAP group for admins is AD group 03. So if I log out from my session and I will log in as AD user 05, which is the privileged user, I can basically see the same because there's no difference. And if I will use some unprivileged user, like this one, I will see just the projects which I can create, list, or put there some data if it's necessary. So let's move to some, wait a second. Let's move to the Harbor Helm charts section. So where you can see how to work with Helm charts in Harbor. Right now, I will log in again as admin. And you can see there are no projects, only the default project called library, which is public. So I'm going to create my own. You can again use the web interface if you want. And I just created through the RESTful API my project, which is private. I will create some my test environment in my Kubernetes cluster. And at the end, I will clone the Harbor Helm chart directly from the GitHub. So that's basically what I used for the installation. Because I don't want to write my Helm charts. That's the reason why I'm cloning it. In the Helm charts library, there are the standard files like values YAML, chart YAML, and templates directory, and a few more. So that's what I'm going to push into the Harbor. So let's add the library project into my local Helm chart installation or into my Helm installation. So I just add the repository to my local machine. And now I'm going to push the Helm chart, which was cloned previously, into the library. So you can see if I open it, it's here. It depends on the information which developers put into the Helm chart, so you can see it here as well, or you can also see the Markdown README file. If you can see, if I list my repositories, the library is here, pointed to my Harbor instance. And if I look for into the library project or the library Helm chart repository, I can see the Harbor with this version is already present. Of course, if you are interested in security, it may be quite handy for you to upload the Helm charts which are signed by the PGP. So here I just created the PGP signature. It's not important how I did it. Everything is in this document. So if you are interested in all the commands, feel free to get it from there. And for the second example, I cloned Git Helm chart, which is a Git repository. I will show you in a minute. And again, it's standard Helm chart repository with all the files. And I'm going to use the Helm package command with these variables to create the Helm chart archive together with the proof file. Proof files is something like it's basically signed. It's signed file. It's PGP signed, and there is the signature. If I will use the web interface, I can also use the upload button here, and I can put here the Helm chart, and optionally I can use the proof file as well. So let's put it here. In my case, I'm uploading both of the files. And in this next command, I will use the Helm to install the Git directly from my Harbor instance. So that's presented by this string. So I just finished with the installation, and if I open it, it should appear. Yeah, let's scroll down a little bit. Here it is. Okay, so it's not there. It will just take about 5 seconds or 10 seconds to start. So it shouldn't take a long time. Yeah, here it is. So, and now I'm able to push my application code into these repositories or manage users, organization, etc. But more important stuff are coming. Let's see how we can work with container images. So for now, I will log in into the Harbor, again using some Active Directory user. Successfully downloaded, and because I don't want to build my own image because it takes some time, I'm just going to download the container image from the from this URL. So it will just take a few seconds. It's a short one, and I will open the repositories. You can see it's completely empty here. I will tag the container image and prepare it for uploading into this Harbor instance. So let's put it there. And you can see in a minute it should appear. So now the people who has access rights to this project, they can use it. If I click on the image, I can see all the tags which it is using and few more information, but there's not much interesting right now about it. Also, you can see the build history, how the image was built actually. Of course, again, the enterprises, they usually want to sign the image. So here's again, some more examples how to use the notary, and Harbor will automatically recognize the signature. So I'm just creating the basics login name and password, which I will use for my signature, and I will push again this image into the library repository. So let's open the library project, and nothing's here. I'll put it in, and here you can see that the container image was signed. If I refresh the page and click on the image, you can also see it here that it's successfully signed. If you want to get more information about the image, you can download the notary client and use it to query the notary. And notary will give you some more information about this signature. I'm not sure why it's not downloading. Yeah, it's just slow. So here's, for example, the digest. The notary can do much more, but this is just a quick example. In this example, this is the only time when I'm using the notary.mylabs.dev. So the notary interface is, let's say, separated from the Harbor. Here are just a few commands which are checking if the vulnerability database was successfully updated, but we also check it here, and so it's fully updated. So I should be able to use it. Again, I'm going to the library project to see if there are any done on my image, but nothing's there. Here, I should also mention that you can query the Harbor through the RESTful API, and it will tell you which operating system it is supporting for the vulnerability scanning and when it was updated. So let's go to my project, and you can see the vulnerability scanning hasn't been done on this image yet. So let's just do it. Again, you can use the scan button here. So this looks like that there is no vulnerability, everything is fine, because it's just a Go binary, so it's pretty easy. Not much to see. But in this example, I would like to use the 1-year-old Nginx image in this version, and I will upload it into the Harbor. See something more interesting. So again, it's going to be uploaded into the My project. Here it is. Still, it hasn't been scanned yet. So let's perform the scanning. Yeah, it will probably take a few seconds. But right now you can see if I put my cursor on the vulnerability bar, you can see that there are some highly rated vulnerabilities in this image. If I want to see the details, I can click on the tag, and I can also sort the vulnerabilities by severity. Harbor will also tell you which package contains the vulnerability. It's a glibc in this version, and in which version this vulnerability was fixed. So you can also get some more information about it by opening the vulnerability, or you can click on the vulnerability itself and check it on the Debian page, where it's much more detailed here. Again, here's some summary of the vulnerabilities. So that's, I think, pretty handy for everybody who takes care about the security and container images. Let's move on. I will come back to the vulnerability scanning in a minute. But first, I would like to tell you more about the replication. If I want to replicate some image from third-party container registry, first I need to create a registry itself, a registry endpoint. So in my case, I will just create the Docker Hub endpoint. Nothing here except the URL, that's the most important one. And if you need, you can also fill the login credentials. Then you need to switch to the replication tab and create a replication rule. This is much more complicated, but let's just create one. And here you need to specify the registry in manual replication or scheduled replication, which is based on cron scheduling. So this is what you need to prepare. Now, if I just initiate the replication, again, I will use the API. Your application should be in progress. So it just started. If I click on the replication ID, I can see here the details. Let me make it bigger. So you should be able to see source, destination, the operation, and some information about the time. Logs are available as well, so you can see if there are any problems with downloading the image or if everything is running fine. If I go to the projects into my library, I should see this is the Hello Kubernetes container image, and here are all the tags which were replicated by this replication rule. To be sure that it's really replicated successfully, I will run this application. So you can see it's using my Kubernetes cluster is using the image from my Harbor instance. That's the Hello Kubernetes application. And if I open the proper URL, I should be able to see it. Yeah, here it is. So that's the application. It's just a simple web page. Yeah, here it is. Another few things which I want to mention are project settings, because some of them are really handy and you should know about them. So if I will go to the library project, to the configuration of this project, you can see there is one of the option is vulnerability scanning, and here it's mentioned that every image which is going to be pushed into your Harbor is going to be automatically scanned for the vulnerabilities. That's pretty handy, and I definitely recommend you to turn it on. So let's do it. And if I will upload my Nginx to the Harbor, like I'm doing it by this command, docker push, it should appear here and the image should be automatically scanned. So that's basically what you saw before, that this is the really old Harbor image, Nginx image. Another example which you can do right now in your environment is that if you're already using some third-party container registry, or you are using the container images which are running your application, you can just install Harbor and let Harbor replicate your images and do the vulnerability scanning there on these images. You don't need to switch to Harbor. You don't need to do any complex migration. But if you just want to know if your images are safe or not, this becomes handy as well. So I just wrote a short script which is replicating the Istio demo images. That's the book info application, which is used by the Istio guys to present the features of Istio. It contains about 6 images, which you can see here. And I just create a replications rule, which will download all these images with their versions and push them into the Harbor. And because it's going to be pushed into the library project, where I configured the settings which automatically scan all the incoming container images, then all these images will be automatically scanned. So let's see how the replication looks like. So here are the replication of all the images which I mentioned. If I go to the library project, here are the images. Some of them are still on the way because it takes some time. But anyway, if I click on the image, I can see that already one of the tags were already scanned. It will take a few seconds, but this is basically the way how you can easily check all of your container images which you are using if there are any security problems right now. So you don't need to do anything else. I'm not sure if there will be something more, but it will probably take some time for Harbor to scan it. Yeah, here you can see it's nicer. So most of the images were scanned, and again you can see there are some vulnerabilities inside the images. So let's move on to another settings. So if I go to the library project again, there is one more settings which I want to mention, and it's prevent vulnerable images from running. It's this one. It means that if there are any vulnerabilities found in your images and the severity is higher than some kind of threshold, then the harbor will not allow to download these images, to pull the images from the harbor. So let's turn this on and see it on in the real example. Let's refresh the page. Yeah, now it's turned on. And I will again go back to my repository. You can see this is the QART image, and if I wanna run it, it shouldn't be a big deal because there are no vulnerabilities in this image. So if I run the image, I should be able to see if it's running or not. Yeah, that's the application. Nothing complicated. It's just a simple Go binary. But of course, I would like to run my engines, which has some vulnerabilities which are marked as high. So let's get back to the project repositories. So it's this engines, and as you can see, that's the one which I showed you before. And if I wanna run this image, Kubernetes will not be able to download the image because Harbor will not allow that. So here you can see there is a problem with pulling the image from Harbor. If I display the details from this spot, you can see that there is the reason why it's not possible to pull this image is that the severity of vulnerability of the image is high, which is higher than the threshold which was set. So that's basically the reason why I can't run this image at all. Again, that's pretty handy if you are running some production environment. Last thing I wanna show you is just a simple airbag example. So I will create a new project, this one, and as a standard unprivileged user, I would like to push there the image. First, of course, I need to log in as the user, but because this user is not privileged, I will not be able to upload the image because I get access denied. So what I need to do is just click on the member and add this user into the group, into the project, which I will again do by the RESTful API. So the user should appear here, and now you can see that it's the user role is developer. So this user should be allowed to push the images into Harbor. And now everything works like expected. So here's the image. So that's pretty much all from the demo, but I would like to also give you one slide about the future plans for Harbor. It's version 1.9, which should be released in September. And what I saw on the developer meetings is that they are going to implement the quotas, which is a very handy feature because right now all the users can put as much as images as they want. And of course, they can easily fill up the disks. So it was one of the requirements from the enterprises that the quotas should be introduced in Harbor, and you can limit, or you will be able to limit the number of the images and, of course, the total size of the project in gigabytes. So that's pretty handy. Maybe there will be another feature which will be implemented in this version, retention policy. So you don't need to store the images which are, for example, 1 year old. Depends on your settings, but definitely not for some development images. Another great feature which I saw is that you can mark some CVEs, and Harbor will allow to download, to pull the image with the CVEs, which are marked as, which are on the whitelist. It means if there is a really new vulnerability found in, for example, in your Debian image, and it usually takes, let's say, a week for example, for Debian developers to fix the issue and put it back into the container image. But of course, you need to run your environment all the time. So that's why you can put this CVE on the whitelist, and even if you have the settings which I showed you before, the Kubernetes or any other instance will be able to download this container image with this really new CVE. That's again handy for the enterprises. And one more feature which developers mentioned is that there are going to be webhooks implemented. Means if somebody will upload the new image into the Harbor, then Harbor can be configured to call the webhook, and you can react on this somehow. So that's again pretty handy, for example, for the automation, or just for letting people know that, okay, the new image was uploaded and you can use it in your CIs or wherever you want.
Right.
So that's pretty much all I wanna share with you regarding the Harbor. If you will have any questions, or if you wanna see all the commands which I was using building this demo, you can check it on these two URLs, which Michelle or Nick will send you later today or tomorrow. So that's pretty much all for me. So I'm passing it to Nick.
Okay. So just really briefly, we're going to go ahead and try and do some rapid fire answering of questions. So throw your questions in right now. We only have a few minutes, but we'll get to as many as we can, and we'll see what we can do. While you're doing that, just really quickly wanted to let you know that because you came here today, you have a special discount. So you can get 15% off of Mirantis training. We've got a bunch of Kubernetes and Docker classes. They're terrific. And also the Istio Fundamentals class is now live. So I would encourage you to grab that code and jump in and take those classes. All right, so let's see how many questions that we can answer really quickly. Peter, can Harbor store images in some external storage, or does it rely only on Kubernetes persistent volumes?
Yeah, that's a good question. As far as I remember, in the HELM chart, I saw the possibility that the Harbor can store the images in S3, so you can use the external storage. Definitely, that's the best way, I guess. But in my case, in the demo, I was just using the standard EBS, which are located on the Kubernetes nodes, which is not a recommended way for the enterprises. So the answer is yes, Harbor can do it, but I don't remember from the top of my head which other external storage are actually supported, but I remember S3 for sure.
Okay. Can I replicate an image from ACR to Harbor, or Harbor to ACR, or ECR or GCR?
Yeah, I believe the Azure Container Registry is currently only available in the master, so it hasn't been released yet. I expect that it will be in next release 1.9, released in September. And as far as I remember, you should be able to do that. So definitely ACR to Harbor and Harbor to ACR should be working. And Google Container Registry, I'm not sure about that, but most probably it's supported as well. But I can't guarantee that because I haven't tried it. So all these possibilities which were mentioned, ACR and GCR, Azure and Google, are going to be in the next Harbor release.
Okay. Is there any form of notification, for example, to send an email when somebody pushes an image?
I don't think so, because that's basically the reasons why the webhooks are going to be introduced. So currently, there is no way how you can achieve that. I think it's pretty reasonable request, but not right now, I guess.
Okay. Last question. I believe this is the last question. How is high availability handled in Harbor?
Yeah. So if you are running the Harbor using the Docker Compose, for example, then the only way how to achieve it is that you will have multiple Harbor instance on the different virtual machines, for example, and you can also share the storage using cluster.fs, for example, between these virtual machines. But of course, the best way or better way is maybe to use Kubernetes, where you can easily scale Harbor, or you can tell to the Helm charts, okay, I need 3 Harbor core components which are going to be running on my Kubernetes, and then the HA is much more easier than on, for example, virtual machines. Of course, also the good idea is to use S3, as I mentioned before, for storing the images on the S3, and you should also use the external, for example, PostgreSQL server, which has its own HA.
Excellent.
Application. So that's probably
all right. Okay, so I hate to cut you off here, but we are at the top of the hour. So I want to go ahead and thank our panelists today, Peter Rushika. This was very interesting. Thank you so much. And as always, our super producer, Michelle Yukura, thank you so much for everything that you do. And we want to thank you all for joining us. We know that you're busy, and we appreciate you taking the time. And I am Nick Chase, and we'll see you next time. Thanks a lot.